Look at this map. Every dot represents an ordinary police record from a mid-sized city. By the time we plot all 12,847 records from the last year, the map becomes a cloud of unreadable static. If you were handed this raw dataset and told to find the story, it's not immediately clear where you would start. There is no obvious pattern here. We often assume that if we collect enough data, a single, objective truth will eventually present itself. We wait for the numbers to speak. But data is passive. It doesn't have a voice. It acts more like a mirror, reflecting the specific framing of the inquiry we choose to apply to it. To demonstrate this, we're going to take this exact dataset, without changing a single value, and ask 4 different spatial questions. Each question will produce a different map, showing how the results of an analysis depend more on the person asking the question than the numbers in the spreadsheet. We start with the most common question: which neighborhoods have the most crime? We count the incidents in each area and shade by count. This shows where incidents happened, but it doesn't explain why. Often, a neighborhood with more crime simply has more people living in it. You're mapping population, not necessarily a crime problem. To see past the population, we have to change the question. Is the crime actually clustering, or is it just following the residents? This is a hotspot map. Once we account for population density, we can see where crime is statistically concentrated. These red zones are where the activity is higher than what you'd expect for the number of people living there. Notice that these red zones are in different neighborhoods than our first map. The areas with the highest raw numbers are not the ones with the genuine concentration problem. If a city relies on the first question, it sends police to crowded neighborhoods. Using the second question targets the actual anomalies. Now we can add the element of time. Our third question is the crime pattern moving? When we group these records by quarter, we see that the activity isn't static, it's shifting. This orange arrow shows the center of crime migrating across the city from January through December. This changes the strategy. The hotspot map shows where crime was in the past. This space-time map shows where the activity is heading right now. We can go a step further and move from description to prediction. What predicts where crime will increase next year? We take our original records and layer in variables like street lighting, vacant buildings, and transit proximity. This creates a predictive risk surface. These blue zones have no crime problem yet. On today's hotspot map, they look fine. But the underlying conditions suggest that these areas are where the next increase will likely happen. By asking a predictive question, we can see vulnerabilities that the historical maps can't detect. Here are the 4 maps. Each is a valid analysis of the same 13,000 records. The data didn't change, only the question changed. Depending on the framing, you get 4 different sets of instructions for how to run a city. This is why vague prompts are a risk in the age of AI. If you ask an AI tool to simply analyze this crime data, it has to choose one of these 4 approaches for you. If the AI defaults to the first map, the simple count, it provides a technically correct answer that is strategically useless if you actually needed the predictive model. An AI can process thousands of records in milliseconds, but that speed only matters if it's paired with the precision of the prompt. The data is just the raw material. The analytical power of the result is determined by the question. The person who frames the question controls the insight. In an AI-driven era, the ability to think spatially makes the human element necessary.
The question dictates the map. In the next video, we see how vague prompts lead to failures and why your human judgment is the only defense against it.